Okay, good afternoon, everybody. First, I want to start with assignment 2, like actually the projects you're going to make. There is just like one project so far here. So I want to know like what is a status, who has the team and idea, and who is alone and looking for the team, yeah?
We have a group and we thought we were going to make a racing game because making an engine seemed maybe a bit difficult, and also it's more straightforward in what you're supposed to do if you just make a racing game. So we're going to make a racing game. We haven't written it up there yet, but we're going to.
Okay, so didn't exactly get it. Did you change your mind, or you were still working on racing game?
We changed our mind.
Okay,
we
all
were
right.
going to make an engine, but then we came to the conclusion that none of us were really extremely motivated for it. And to make an engine, you kind of need to be motivated for it. So instead, we're going to make a racing game, because then we know, then we have a clear line of progress, and then we can more easily figure out what we're supposed to do and do it.
Okay, you have your team.
Yes.
Yeah, that's great. So anyone who doesn't have a team and has some ideas and want to find someone, yeah, you can feel free to come and discuss your idea, and maybe you'll find a teammate or something, or you can say from there.
Well, I was actually also planning to do a racing game. Sort of. It's a racing game in space, basically. It's sort of like Star Fox plus F-Zero, where you can shoot the other racers and stuff. And there's like destructible obstacles that drop items that boost your speed. Basically, it's a high-speed racer in space that you can shoot stuff. Yeah.
Oh yeah, that sounds interesting.
Yeah.
So yeah, if anyone everyone else kinda already sure who they are working with and what they are going to do, or? So yeah, if any of you are interested in his idea, feel free to collaborate, or just like make groups, and then you'll see. Because I think that for one person, the scope is pretty large of the second assignment. So it's, for the first one, it still was okay, and it was just 10%, but now it's larger scope project. So I think it will be very nice to work in groups. We were just discussing assignment 2 groups. So do you have your group, or did you decide what you're going to work on? So you're good with it? Yeah. Okay, great. All right, yeah. So feel free to collaborate with each other, change ideas, and build the groups, because yeah, for a single person, I don't know, it's pretty large scope. Bear that in mind. Yeah.
Also make sure to put yourselves into a group assignment, or
yeah.
allocations, I mean.
Yeah, so yeah, don't forget to kinda write the summary of your project here, title, URL to the repo, short description, logic, like stuff you're gonna do. A simple summary, so that the reader had an idea what is it about. And also it's good for us to know that, okay, who is doing what and where they are. Okay, let's start with the lab. So if you go to the wiki week 10 and go to OpenSceneGraph page, yeah, so we did what we did discuss yesterday. Who remembers, who can kind of summarize in a sentence or two? So what was yesterday's topic? Yeah?
Scene graphs, which is a way of keeping track of the entities in your scene, I guess, or models.
Yeah, that's right. Would you like to add anything else? Sorry. Some of you from the back wanted also to answer. You want to add anything?
No, it was just that it was OpenSceneGraph, and that it was essentially a powerful tool with documentation that helped you keep shapes to be the same when you modify certain values, because the topology or the other one was
geometry?
Geometry, yeah. One might change and then the other one might be the same, but or they might be some do the same value and it doesn't stay the same shape. But if you use OpenSceneGraph and connect things correctly, you can make it stay the same shape using it.
Well, this was more on mesh level. Geometry topology was mesh level, but SceneGraphs can help you to keep the relationship between different meshes, different drawables. That was the logic. But yeah, it's good that you remember that, like, the first few slides were about meshes and how to represent and organize the informations about meshes. And mesh is just like the final leaf node in the tree that is drawable. SceneGraphs deal mostly with the relationship between those different meshes, different shapes, and the properties they share. But yeah, that's very good that you kind of got that first few slides about meshes, topology, geometry. That's very important. Okay, today's lab is SceneGraphs, and which tool did I discuss last time?
SceneGraph of the open variety.
Yeah, OpenSceneGraph.
So of
Nice
the
try.
questions and the answers right on the screen.
Yeah, that also shows how attentive you are. Yeah, today we're gonna play with OpenSceneGraph. So here is a link to the website where all the documentation that is not very good, but there is still some, is, and you can find all the info you need. And what you only need to do is to download first the kind of core resources of the OpenSceneGraph, build it using CMake, and then you need to download further resources that you need for the examples. So here are the instructions, what you need to download, and how you need to link it with the core resources. And there are like lots of interesting examples. Some of them might not run because resources are missing, but I will show those ones actually. Those two are very good examples of this hierarchy and the link between different objects. So at first, as far as I understand from running the example, they are all bound together. So when you interact with one, all others have the, for example, if you have a translation matrix for one, all other objects also are being translated with the same matrix. But you can play with different joins, change these hierarchies, dependencies, and see how it impacts interactivity. And you can also load other models within this example and play with it. But yeah, first it's good to show some of those examples. Oh, I don't know what's wrong. So it's half seen. Oh, okay. Half of that is on my screen and half of that is there. Let me change that. Okay. So this is one example, planets. And you can interact with them, move them while the sun remains static. And you can change, like, try to change the rotation speed, etc. So this is one example. Another one that is very good for illustration of hierarchies is robot. Yeah, here it is. So this one. So right now all those ones are kind of attached to the main body. So apparently in the SceneGraph they are grouped together, so you can try to play with the code and make them independent from this rotation, for example, or change other stuff in it. So you need to first build this and then look into robot.cpp and understand what's going on there. So you feel free to explore that. So that's examples. And yeah, for Visual Studio users, it's good to run that from the command line, because otherwise you might not get clear feedback on the errors, what's going on there in the Visual Studio. And yeah, if you go to the website, you will find some documentation, and this tutorial is very good. It's the one I mentioned on yesterday's lecture. So the coding part is, I think, mostly about Java, but you can get the key ideas and principles out of it. So here is a pretty good tutorial explaining most of the stuff we discussed yesterday. Like these ones, for example, I think they look familiar. So yeah, first download the resources and then feel free to play with them. Any questions? Yeah?
How do you build in Visual Studio with a command instead of just doing it through menus?
Sorry, could you repeat?
How do you build it using commands instead of just using the GUI in Visual Studio?
No, I meant when you build it, try to run from the CMD. It's what we mean there, right? Yeah, I think so.
Okay.
So when you build it from Visual Studio GUI, then try to run like I did this one in this case. Where is it? So I did from Windows right now, but I could run it from CMD. But if I run it, some of them from CMD, I get the errors if there are any. So in this case, okay, this runs all right, but some of them do not. I don't know which ones aren't working. Yeah, I think there was an error, some file not found. So if you build everything and then try to go to this folder in your command line and run this OSG light D, you will get the error, whatever is there. So that's what we mean there. But when you have your source, you can build from Visual Studio as usual. But to run the solution, then to launch it, try to do it from command line. There was also a batch file, I think, but I didn't. Yeah, you can also try to use this batch script to run the examples, but in my case it didn't work, and I don't know why. Maybe due to the hierarchy of the folders here, but like you have this one and you can check it out also, like the script that tries to run all of them one by one.